हेलो।
हाँ ज्योति, बोलिए।
Are we starting, sir?
The first speaker has come.
Yes, Avik sir has already joined. I think we should start.
Yes, please go ahead. Once Avik sir is done, then I will be asked.
Yeah, he has joined. I can see, sir.
Okay,
So
so
if you can request Avik sir.
good morning, ladies and gentlemen. A very warm welcome to each one of you joining us today for EE Auto EV Summit 2026, empowering a net zero emission future. As India accelerates towards becoming a global leader in sustainable mobility, today's discussion will focus on technologies, policies, and innovations shaping the future of electric mobility and clean transportation. On behalf of TechZone Print Media, our supporting partners, distinguished speakers, industry leaders, researchers, innovators, and everyone joining us virtually. Thank you for being with us. Over the next 2.5 hours, we will hear insightful keynote addresses, engaging panel discussions, and interactive conversations covering India's EV policy landscape, battery innovation, charging infrastructure, smart grids, and the road ahead toward achieving net zero. Without further delay, let us begin today's program. Now, to set the context for today's discussion, it is my privilege invite our keynote speaker, Mr. Avik Chatterjee, General Manager, Automotive Electronic Department, AI, with decades of experience in automotive technology and policy implementation. Mr. Chatterjee has been closely associated with India's evolving electric mobility ecosystem and has played an important role in advancing automotive innovation. Ladies and gentlemen, please join me in welcoming Mr. Avik Chatterjee for his keynote address on EV regulation and future mobility. And before he started, I like to request each one of the audience not to take any screenshot of Mr. Avik's presentation, as some of the documents which he is going to present and show to us are confidential. Thank you. And I request Mr. Avik sir to take the stage.
Yeah, first of all, thank you very much for giving me this opportunity. Am I audible?
Yes, sir.
Yes, sir.
Yeah. So I'll share my presentation. Just give me a minute. Is it okay? Can you see this?
Yes, sir. It's visible.
Hello?
Yes, sir. It's visible and you are audible as well.
Yeah. Okay. So basically, today I'll be speaking on the EV regulations and future e-mobility. So here, the need of EV regulations when it was failed, and why it was failed basically. So due to this government's initiative for the e-mobility, so for the vehicle safety and traction battery safety, so that is the first thing why regulations are important, because these are all working on the lithium-ion chemistry, these battery packs. So the safety is the most concern. Then protection against fire and explosion. Then protection against any accidents. That's very important. So for that we need the traceability of our component, each component in an electric vehicle. Then your traceability of the charger, what you are using of the electric vehicle. So these are all important for the EV the need of EV regulation. So you can see the category of the vehicles, electric vehicles in India. So these are they're using a lot of different categories now. So for specific use, you can see agricultural tractor and the regular what we see every day on the roads are 2-wheeler, 3-wheeler, 4-wheeler. Buses are also used. So the n number of categories which are used on road today. So if I go deep into regulation, then I can say when we say as L category, that means 2-wheeler and 3-wheeler categories, then we are using regulation 039, 40, 41 and 156. So these are the different regulations for range. So when you go to a shop, you can say when you buy a EV, you will ask a range of a, so range of a vehicle has to be tested. As you when you buy a ICE vehicle, so you ask the average of the vehicle. So here we ask normally what is the range of the vehicle. So the range has to be tested under some conditions. So and then energy consumption test we have to do. Then safety, whatever I just spoke, the safety has to be tested. So these are the different regulations for 2-wheeler and 3-wheeler. Then when you go to higher category, M, so it's called M and N, so passenger car and above category, truck category. We use the similar standard, but the cycle is different. So for that 39, 40, 41 the same. For the safety part, we use AIS 038. So these are the two difference. And then when you go to other category like fuel cell vehicles, we have to hybrid vehicles. And there are other regulations like 157, 168 for agricultural tractors, CEV for 174. So these are the different regulations what is already existing in India. When I say AIS means automotive industry standard, and these are all for India specific. So when I say as India specific standard, but we have referenced it from somewhere else. So that reference we have taken, as I have shown here, like 156, it has been taken from even so even regulations, United Nations regulations are 136. When I say consumption, energy consumption and range, it has been taken from 101, and motor, so it is taken from R85. So there are different referencing we do from European standards. Now, what test we do? So in short, in a vehicle, we do functional test as per 038, electric shock, then we do safety test and performance test. So performance, I already told you, this is range, energy consumption, power, credibility. So this comes under the performance. When I say about the safety, so your electric shock, water effects, these safety, so that comes under safety. And there is some part that comes under verification, like lighting and signaling. When you say telltale, so what is indicated on your cluster. So for example, thermal propagation. So that also you have to check on a cluster and as well as on the component level. So I'll go in short because our time is short here. So you can see there are some equipments shown here. When we say electric shock has to be tested, then there are some probes that has to be with which we check the electric shock. Then high voltage marking should be there because they're all high voltage components, battery, motor, DC-DC converter. So there, this high voltage marking has to be there. And then audio visual indicators for active driving mode need to be there. Then onboard indicators for SOC, for example, when there is a charging indicator. So for example, what is the state of charge at any point of time? That has to be indicated on the cluster. So these checks are done at ARAI, you can say at a test agency, where we ensure the vehicles has to be checked as per this standard, and then the vehicle is released on road or it is launched, you can say. Vehicle has been launched in market. So yes, we are using different cycles now, 039 for energy consumption, 040 for range, and max power test. So now when I go to deep down for the battery packs, you can say there are different tests we do in the battery packs. For example, we do now when you see in the battery pack, there are two standards, you can say. One is 156 and 038. So from mechanical test, from vibration, mechanical shock, to thermal test, we do fire resistance tests, and we do thermal propagation test, and then also electrical test. So there are three basic categories of test we do. Electrical means overcharge testing, over discharge protection test, over temperature test. Then we do short circuit test. So these are the different categories of tests we do for an electric vehicle. Then inside also, not only battery pack is tested, the cell level, and cell also has to be tested, and with the standard called IS 16893, and this has to be tested for also different norms, like you can say overcharge, over discharge, then short circuit. This has to be tested for all those parameters also. Similarly, BMS safety is a part, so BMS has to be also tested here. Then charger has to be there, because whatever charger you are testing, so that pair, battery and charger, that same pair goes to the market. So battery has to be tested with its paired charger only. Then you have pack level safety, like for example water immersion test, then audio visual test, regeneration, then there should be 4 temperature sensors in the battery pack. So these are all different test concepts. You can say onboard charger, you can see there are a number of tests, like over voltage cutoff we test. Then we change the pre-charge function or soft start. So these are the different tests of the onboard charger. When you go to cell level, so cell is tested for at least 1 cycle of charge discharge. So, and this data has to be available with the battery pack manufacturer. So these are the rules, we can say, that we have to follow in future. Not only the testing is done and it is completed, that data has to be there with us, so that for any emergency the data can be retrieved. So then this I already explained you. Then there are some things like pressure vent in a battery pack should be there. So previously when we used the different like lead acid battery packs and all those, so pressure vent were not there. So this has been made mandatory here. Then BMS has to have some data record at least for 1 month. So these are there's these critical parameters of BMS data logging should be there, and it has to be kept. It has to be preserved for at least 1 month. So similar way, AIS 038, I will not go into again detail. Similar way, AIS 038 also, there are a number of things like 156 is almost similar. I'll go there. Now the testing is done. Now we have to do a conformity of production. So this is done almost every 2 years, and now it is done as per the AIS 037. So there we have to do a plant audit, battery plant surveillance audit, and we have to see the tag, whatever the tag, for example, type approval certificate number, the TAC number is issued during the test, that is engraved on the battery, and there are different small things that are being checked, and also testing is done as per the COP. So you can see there's a continuity of the test is being done for the EV. So now first is cell is tested, then battery is tested. Once battery is tested, then you have a COP, conformity of production, after every 2 years, and then after this also that you have a vehicle testing. So vehicle is also having a whole vehicle safety COP. So this way we are ensuring your standard, the EV is tested as per the standards. Then government has taken different initiatives like e-mobility government initiatives. You know, there are some FAME word is there. FAME is a national mission on electric mobility. So now the FAME is renamed as PM e-drive scheme. So it is still ongoing. It is still ongoing in India. Now in area we have different facilities. So now this is one of the battery testing facility. This is tested in under one roof. So all the testing from vibration to mechanical shock to your thermal propagation, everything is done under one roof. So these are some facilities what is required, and these are very expensive. And then when you come to two-wheeler three-wheeler testing facility also we have. So this is a two-wheeler chassis dyno facility. Chassis dyno is required for this, obviously, for the range and energy testing. Now there are some, when I say future e-mobility, so future is like what we are testing that is under 25 degrees centigrade still. But then there are some new norms that you have. So for example, you are driving a vehicle from Bangalore to Ooty or from Pune to Lonavala. Then obviously you are driving with your AC on condition, and you are driving under the solar load because the sun will be there. So that the same condition was not tested before. So now the new cycles, what has been done, that is AIS 213 standard, that will, in that vehicle will be tested in the realistic road conditions, where the solar simulation will be there. For example, 780 watt per meter square, and under 35 degree centigrade, and humidity 45 degrees percentage RH. So that is where we will come to the realistic range and realistic energy. Similarly, we have a new cycle that will be implemented from April 2027, that is WLTP cycle, Worldwide Harmonized Light Vehicle Test Procedure. So here also you get the realistic conditions. For now, for the car, we are using MIDC, but in future you will be having this WLTP cycle. So that will be tested as per AIS 175. Now there are different, these are also new standards, for example, battery durability standards. So here the manufacturer has to certify that the battery is fitted in their EV will lose less than 20% of whatever initial capacity been specified before 5 years, or 1 lakh kilometer, and less than 30% over 8 years. So this will be tested. Battery of that vehicle will be tested accordingly. So this way we will be ensuring the entire EV ecosystem. For example, we are testing the entire components. We are having new regulations, and ministry and government is also giving new initiatives, and this way the e-mobility and the future of e-mobility will be ensured. Not only that, I have some other examples. For example, when we say now EVs are all connected, so in this connected ecosystem also we have new standards. For example, we have standard for automotive cyber security. So there AIS 189 and AIS 190, these two standards will be coming into picture. So what is AIS 189? We need to test the vehicle as well as the vehicle entire ecosystem, where you are from design, development, post-production, the entire part of that vehicle has to be tested. So the plant audit will be there, and also the vehicle testing will be there as per the 189. Similarly, for AIS 190, AIS 190 is whenever you are doing over-the-air updates, OTA. So for that, or any updates, for example, wired updates also, this AIS 190 will be applicable. Here also there will be two parts. One is organizational requirement, and second is vehicle type approval requirement. Whether so your entire organization level will be audited, and you will give a compliance. And similarly, your vehicle has to be tested for all these regulations. So ARI is providing the entire services under this. So certification to development, and to on the entire consultancy part. So this way, just let's work together for cleaner and secure tomorrow. So thank you very much. I think I am able to explain you the intricacies of the e-mobility.
Thank you, Mr. Chatterjee, for sharing such valuable insights into India's policy direction, infrastructure priorities, and the opportunities that lie ahead in our EV journey. Now, I would like to invite our moderator, Mr. Vishwas Das, to engage in a brief conversation with Mr. Avik Chatterjee and ask a few questions to further explore his perspective on the future of India's EV ecosystem.
Thank you so much. Good morning, Mr. Chatterjee. I hope I am audible to you.
Yeah, you're audible.
Yeah. So first of all, thank you so much for joining us in today's event, and that it's a pleasure to host you here. And it was very engaging presentation that you took us through. Uh, I wanted to ask. I have three set of questions for you, Mr. Chatterjee. So first one is like, I wanted to ask you about how is India's evolving regulatory landscape enabling the country's transition to electric mobility.
Can it be please be a little bit louder?
Yes, of course. I'm repeating my question. Uh, Basically, I'm rehashing my question. The question is, what are the key policy and regulatory frameworks governing electric mobility in India, and how are they shaping EV adoption in the country?
Yeah. So see, as I was explaining, so when you come from the lead acid battery pack to lithium ion, so the standards have also changed. For example, from AIS 048, so that we have changed and we have adapted the new standards from the industry, from the UNR, and also we have done we have taken the Indian specific conditions and we have incorporated those in our battery standards also. So AIS 38, AIS 049, AIS 39, 40, 41. So these are the different regulations, whatever is already existing in India. But what happens, not with all these standards also it doesn't help. So we need some push from the government, we need some push from the industry. So now the complete push is there from the industry. We have PME drive schemes or auto PLI schemes, you can say, and auto PLI SEC, PLI SEC schemes are there. So there for sales, one is for component, and as well as OEM, and PME drive scheme is for OEM and for vehicles basically. So these are the schemes which are enabling us to go through to you can say develop the ecosystem, and we can proudly say that India is marching forward towards complete e-mobility.
Right. Thank you, Mr. Chatterjee. Chatterjee, that brings to Mr. Chatterjee, that brings to my next question, which is how do you envision the future of e-mobility, particularly in the context of connected, intelligent, and interoperable mobility ecosystems?
Yeah. So now when I say connected ecosystem, then obviously first thing will come to my mind is what is connected. So connected means connect your instrument cluster, your entire BMS, your you can say your infotainment system, your motor control unit, the entire part of a EV or a ICE vehicle will be connected. So there will be different protocols into it, like CAN, LEAN. Then you have you can say automotive Ethernet. You have Bluetooth. You have Wi-Fi. So there are different protocols into it. So now you have to have some rules or some regulations to regulate those things. So first regulation we can say that's the automotive cybersecurity regulations what we have already, and now as 189 and 190 we have also draft notification is there. So 189 and 190 will help to secure your vehicle architecture, to secure your vehicle. So that is for security. Secondly, we have ADAS different regulations. For example, your driver drowsiness. We have lane detection, so these are the regulations for ADAS point of view. And when you say e-mobility or you may future, then obviously AI will be coming into the picture. So, but there is no such standards as for AI. But when we are doing all these things, then obviously when you are saying connectivity, then V2X is another parameter, like you can say vehicle to vehicle connectivity or vehicle to infrastructure. So there is another standard formulation going on for the V2X, that is 230 as the this will have to standardize, but that is done on the first phase for the V2V only, vehicle to vehicle. But in future that will be extended to V2 vehicle to network or vehicle to infrastructure part.
Yeah. Thank you for answering this question, Mr. Chatterjee. Mr. Chatterjee, we know that Government of India is proactively promoting EV ecosystem in India, across India. And recently we saw how Delhi government has come up with a new EV policy. So my next question, sir, revolves around government support. What are the Government of India's key initiatives to accelerate the development of a robust ecosystem, including charging infrastructure, manufacturing, and innovation?
Yeah. So because I am working very closely with these schemes, I am doing the assessment and testing under this scheme. So PA mid-life scheme is one of the scheme whatever government has already taken care, that is applicable for 2-3 wheeler, then trucks, buses category, and e-ambulances. Previously during FAME scheme was there, so FAME was also applicable to 4-wheeler. Now that has been taken out, and now it is applicable for these categories. Now we have also PLI ACC schemes, and so for the cell manufacture in India, ACC PLI, and also auto PLI schemes. So auto PLI schemes. So this is not only for OEM, this is also applicable for component manufacturers. So these are the schemes basically that is applicable for in India, and also our government is continuously monitoring the situation whenever there is some threat of, for example, your magnet. There is some shortage in between from the foreign countries and all due to war situation. Our ministry continuously monitors the situation and tries to incorporate wherever it is possible, and tries to discuss with the stakeholders, and tries to monitor these things and modify the standards and regulations and rules accordingly.
Thank you, Mr. Chatterjee, for sharing such insightful perspectives on the evolving EV landscape in the country. Your
Thank you.
thoughts on the regulatory framework, the future of connected mobility, and the government's initiatives to strengthen the ecosystem have really provided our audience with valuable takeaways. And it is encouraging, not for me, but for everyone in this webinar, to hear how policy, technology, and industry are coming together to accelerate India's transition towards sustainable mobility. And we truly appreciate your time, expertise, and candid insights, Mr. Chatterjee. Thank you so much.
Thank you very much, sir, for giving me this opportunity, and thank you to all the listeners who are listening patiently to me. Because it's early morning, anyways, presentation. Once we come to the office and we start this presentation, so thank you very much.
Thank you.
Thank you, Mr. Vishwas Das, and thank you, Mr. Avik Chatterjee, for such an insightful and engaging conversation. Your perspective have certainly set that one tone for today's discussion. With that, we now move to the first panel discussion of the day. As the EV ecosystem continues to evolve, regulations and technological innovations and collaboration across the value chain will determine how quickly India reaches its sustainability goals. Our first panel today explored the latest development in battery technologies, AI-powered battery management, localization, recycling, and the future of sustainability and energy storage. Now, allow me to introduce our distinguished panelists. First of all, I would like to invite Mr. Anshu Diwan, founder and CEO of IX Energy. Secondly, Engineer K. Ravikant, Assistant Professor, Department of CSC, Aurora, deemed to be University, Hyderabad. And last but not the least, Kaustav Dhonde, founder and CEO, Auto Next. Moderating today's discussion is Mr. Vishwas Das, Account Director, Seraphim Communications. Ladies and gentlemen, please welcome our esteemed panel.
Good morning.
Good morning, everyone. This is your host, Vishwas Das, and I'm really glad that all of you have taken your important time to join today's webinar. And I'm happy and excited a lot of earnings which I'm going to have, not only me, but my audience, which are there currently live. So topic for today's panel discussion is building India's EV infrastructure, enabling the next phase of electric mobility. So I would like to begin with Mr. Anshu Diwan, who is the founder and CEO of IEX Energy. And so my question to you is, what breakthroughs in battery chemistry and cell technology do you believe will have the greatest impact on the energy density, charging speed, safety, and battery life over the next 5 years? Over to you, sir.
Thank you so much for that question. While India is a hot, country, and in order for us to have some level of resilience on the battery side, LTO is something we are looking at very seriously. So LTO basically is a chemistry that is resilient at high temperatures, and it has very high charging capacity also. But I think before the battery chemistry part, because that becomes a little bit more technical, I think what we are seeing is in terms of our sorry, I think my voice is echoing. They were saying, just 1 minute. In terms of the ecosystem, I think is very important. So, one of the pain points I see in the ecosystem is, for example, that the charge points basically are desperate for getting regular charging business. And when they don't get that business regularly, then they charge a rate which makes the value proposition for EVs less, right? If they're charging 15, 17, 20 rupees per unit. So there we see that government support is desperately needed, where charging infrastructure companies should basically get a monthly sort of a subsidy from the government to ensure that when our charge point operators, when EV vehicles come, then they are not charged exorbitantly. And I am an operator as well as a manufacturer of retrofit electric trucks, and that is a challenge we are facing. So while battery chemistry is definitely going to be an important aspect of it, and of course costs, what we really feel right now that we need is some level of support, at least at the charge point operators, so that we can make this business really take off. Hello, am I audible?
Yeah, you are absolutely audible.
Okay.
And we have with us Mr. Kaustubh. He's from AutoNext. Mr. Kaustubh, very good morning to you. And my question to Mr. Kaustubh is, from an EV manufacturer's perspective, how are advances in battery technology influencing vehicle design, performance, charging infra, and the overall economics of the mobility?
Right. So at AutoNext, basically, we are building an electric tractor. So we are the pioneers in India who started building electric tractors back in 2016. It was way early for us. We've seen the entire journey of how things have changed in India. Pre-COVID, there was hardly any electric vehicles on the road. Now there are many, and particularly concerning our space, we are into a commercial EV space, which is the fastest adopting space. As you know, three-wheelers are already at 60% in the country. So what we learned is basically initially we had built a lower voltage battery, just like most of the players do. Typically, taking batteries and motors from the two-wheeler and three-wheeler space, but it doesn't work that simply. You need to have a product which is specifically designed for certain use cases, and that's what we did. For electric tractors, we realized that having a bigger battery will not solve the problem. Initially, we had a lower voltage 48-volt system. We moved to a higher voltage 400-volt system. One reason was mainly the kind of torque requirements that we have, especially for higher power vehicles, off-road vehicles, it cannot be managed by lower HP machines. We have to have higher voltage systems that can actually last for higher torque applications. Apart from that, when we put in more batteries, the form factor of the vehicle changes. So it's not just about putting a big box and more kilowatts of batteries. It's about how reliable it is. The entire system works for how many hours. So our customers don't ask us. We're not selling batteries. We're selling the reliability and how many hours the vehicle will work. So it's not just the battery that will take care of this; it's the entire system. And that's when we give solutions about fast charging ability. So our tractors are able to charge on CCS2. Initially, it was just a single phase power supply. So things changed. Post that, we saw the reactions of our customers. They were more comfortable working with adequate battery that can do the task, or also fast charge. So if you put a 100 kilowatt battery in a tractor and expect it to work and do the same job as a 45 50 HP tractor, it is a little bit challenging, because the kind of make the designs of the vehicles are not really designed or not made for having such a heavy battery on the front. So all those things matter, and it's a combination of not just the battery, but it's battery, motor, your charging infrastructure, how fast you can charge your vehicles. And also you need to keep in mind, the most important factor is that the customer who is buying your vehicle, or adopting a vehicle, whether he'll be able to afford a 100 kilowatt battery, even though he needs the vehicle to work for 8 hours. That's the most important factor, especially when you're selling a vehicle in India. And that's what we learned. It's the right balance between all of these factors is what we have been offering. And that is the reason why now we have almost, last year, about 60% of the electric tractors that got registered were Autonex electric tractors. So we've been through the entire cycle, and we believe balance is the most important rather than just kilowatts. Yeah.
Very pertinent points. These are some of the issues or topics which should be kept in mind while buying, EV vehicles. So thank you, Mr. Kaustup, for this perspective. My next question is to Mr. Anshu. Mr. Anshu, I wanted to ask about what are the biggest challenges India faces in building a competitive domestic battery cell ecosystem, particularly around critical minerals, manufacturing capabilities, and supply chain resilience. Over to you, Mr. Anshu.
That's a great question. And honestly, we've been waiting for this for some time, getting an Indian cell from a local supplier. So I think one of the problems we are seeing in this ecosystem, and rather in every ecosystem now, is that innovation is now happening so fast that for any manufacturer to then take a risk on a particular cell chemistry is becoming daunting, right? When we started the discussion earlier, lithium iron phosphide is what the standard majority of the manufacturers are making, and it is improving day by day, right? Every day, every month, the power density increases, the energy density increases, and so there is innovation which is happening at a fast pace there. Then suddenly the cell chemistry changes, and from there you go to LTO, then you go to sodium and solid state batteries. So I think one of the challenges, so we were working with Exide, and Exide had at one time announced that they're going to be putting up a cell manufacturing plant. They'd planned to invest almost $1 billion towards it. But I think somewhere the project is stalling a little bit, just because we feel, we were told that innovation is happening again at such a fast pace that they are not able to understand on which chemistry they want to go for. So that's something which we feel, there's a risk there for any manufacturer, and I think that's the reason why. And of course, the second point that we have faced is the Chinese supply chain, right? I mean, of course, China is watching what we are doing. They don't want local competition in India. So every time there is some announcement, they'll suddenly reduce the prices. And once they realize they are monopolistic, again, they start jacking the prices up. And I think I understand some of those are driven by input costs of the metals that are going inside, but I don't think that's the full story.
Yeah. I also wanted to ask you, Mr. Anshu, about the retrofitting commercial vehicles. So,
Yes.
can you can you tell us more about
Yes,
retrofitting
yes.
commercial
Thank you.
vehicles, EVs?
Thank you for asking that. Yes. So I'll tell you. So what, we were driven by a very simple paradigm, and the paradigm is, if the economics are in sync, then adoption happens automatically without incentives, without any sort of push from the government. And I think the best example of that is electric rickshaws. Right? They started flying in Delhi as early as 2012, when there was no charging infrastructure. There were no incentives. In fact, many of these vehicles were not even registered. They were running illegally on Delhi roads, right? But the reason why they were adopted was because it made commercial sense, right? Suddenly, the owner driver was making 4 times the money with less than 1/10 the effort, right? The cycle rickshaws quickly got replaced by e-rickshaws. So I think that is the crux of how we focus on our business. That look, as long as economics are in our favor, we will see traction. And so the paradigm we're adopting is that, look, if you have an old truck and that is now being scrapped or sold in the second-hand market because of the 10-year regulation, then why not simply convert it into electric and then have it, just have an indefinite life, continue running it as an electric vehicle. And in doing so, you're able to reuse the body, the chassis, and the cabin, right? So the cost of acquisition or the cost of moving towards electric becomes significantly cheaper, right? So that, I think, is something which we are now seeing good traction on, especially with companies now looking at sustainability as a major factor. So like companies like ITC, Dabur are already using our electric trucks for their supply chains. And I think here, in fact, this is one thing where I needed Mr. Avik's contact information. One of the ways where the regulatory mechanism could assist is to kind of give certificates, the type approval certificates, which are a little bit broader. Right now, what they do is, if there is a Tata 407 that we've converted into electric, they will put the exact model number on it. Now, if somebody has a slightly different model, for example, it's an Ashok Leyland in the same category, then we have to go for a type approval extension, which again requires significant testing. So what our appeal to the government is that, look, if you're looking at faster adoption of electric vehicles, look at retrofits as a important category for the lower part of the pyramid, where they may not be able to afford a brand new electric vehicle. We are safe, we are resilient because we are adhering to the same safety test that Mr. Avik talked about. So without that certification, we can't get a green number plate. So what we are saying is, give an opportunity to retrofitters, give the same treatment. Aaj, only a new OEM gets a subsidy under the PME drive. Why, discriminate against retrofitters? ये तो वही बात होगी सर कि मोदी जी is giving subsidies to make toilets in every village. But अगर आपको कोई बोले कि जी सिर्फ इंग्लिश स्टाइल टॉयलेट के ऊपर ही सब्सिडी मिलेगी, इंडियन स्टाइल पे नहीं मिलेगी, so that doesn't make sense, right? We are both helping in that cause of electrification, and that, I think, is an appeal that we are making as part of the Indian Automotive Retrofitters Association also. We are about 28 retrofitting companies in India that are part of this association. I'm the secretary, and we are aggressively pursuing with the MHI as well as Delhi government that give incentives to retrofitters also.
Thank you, Mr. Anshu. You raised really important points, and I'm sure through these kind of discussions and particularly made during these kind of events, government will definitely pay heed to such kind of very important solutions. I would like to now move on to Mr. Kaustubh. Mr. Kaustubh, my second question to you is, what battery technology improvements are most urgently needed to make EVs more practical and attractive for mass market adoption in India? Over to you.
Right. See, to answer this question, and actually, I would like to clarify one thing. India basically doesn't need the world-class, most advanced batteries. India needs most reliable, dependable batteries. That's the difference that we need to first understand. Reason being, we have been always copying what happens in Europe or China. If you look at all automotive standards initially, it all went down the drain the moment all the Chinese scooters came here and started catching fire. We had to start our own strict standards which can sustain Indian environment. Our tractors, for example, they work in 45-degree plus environment, very extremely dusty environments like CBG plants and sugar mills. So those kind of situations are not something that the European or the Chinese are really ready for. They look for ideal conditions, and that's the difference we have to first keep in mind. Our very first priority is of course the battery life. To put extra 30-40 kilometers is not the priority. To have more charging cycles, or that's the most important that customers look at, because they look at how much they're investing. Because for an Indian customer, when they buy a vehicle, battery is not really separate to the vehicle. It's a integral part. If you see, a lot of companies try to do this battery rental option, like MG. You can look at the numbers. Only 15% of MG Windsor cars are sold, in the BAS model. There's a reason. Even though the difference is 9 lakh versus 16 lakh, still people went for the entire car and not the battery, BAS option. So one is that, and secondly, charging speed, of course. So we don't need like 10-minute or 15 minutes kind of charging options, because people can actually, if it fits the exact operational hours, like for example, a person coming in and charging his vehicle exactly when he's coming in for lunch, that's sufficient. You don't really need to go for those kind of options where the battery will last hardly for 1 or 2 years. Uh, Thirdly, basically the temperature conditions. As I talked about, 45 degrees Celsius plus operations here in India. We need batteries that have better cooling, and cooling that is sustainable in such an environment where temperature crosses 45, 48 degrees Celsius. And lastly, and the most important part, which India has been sort of a leader in software development. So the software, has to be really advanced to really help the driver operate the vehicle properly, because you cannot really rely on a driver who has been running a ICE vehicle whichever way he wants, and then expect him to have better life with the EV. So the software has to come into a play wherein the software assists the driver to extend the life of the batteries, to extend the life of the EV. These are the four critical elements that we need to really look at when we look at advanced batteries, developing batteries for India, for Indian conditions. Yeah.
Yeah, I totally agree with you, because you spoke about a tradition or a pattern of copying European countries and China, and the temperature conditions you spoke about, and battery cooling technology. These are very essential points one need to keep in mind. So with this, I would like to move on to Mr. Anshuji. Mr. Anshu, my question to you is, how can India build a commercially viable battery life cycle ecosystem that integrates recycling, second life applications, and sustainable energy storage?
Yeah, yeah, that's a great question, and I think we've already embarked on it. Basically, the battery life for an automotive use is typically up till 80%. So once the batteries, decreases by about 20% in terms of the depth of discharge. After that, it may not be conducive for automotive, but it is ideal, or I shouldn't say ideal, but it is very much applicable for stationary, supplies. So we already have a few companies that have approached us for second life of our battery packs. They've been interested that once we reach our end of life of our battery packs on our trucks, then they'd like to buy it. And that automatically actually makes the economics better for us, because when we are looking at overall cost of our electric truck, batteries are 60% of that cost. And if in that battery, the resale value becomes better because we are now able to use the battery in a stationary setup, then that makes it even better. So I know, for example, a company like JBM is already using some of its older battery packs to start a new stationary business. And we are working closely with JBM on that. Similarly, in terms of recycling, I think that is for the end of life. There are some companies which have already scaled up and are now basically taking full responsibility for ensuring that the recycling is done properly and all the precious minerals are extracted during that process. So it makes the business even more viable for them. So basically, there's a saying in the US that our trash is their cash. That is very true for these battery recyclers. So I think the ecosystem is already starting. And again, I've always been a believer that economics is what drives every is the biggest incentive, and it drives adoption. And I think that is already being seen now.
Thank you, Mr. Anshu. And I would like to move on to Mr. Costo regarding my next question. So I would like to ask Mr. Kostib, as India moves toward greater localization, because we have been talking about Make in India, Made in India. So what should OEMs and technology companies focus on to build a resilient and cost-effective domestic battery and EV supply chain?
Okay. So, see, our experience of developing electric tractor, and I'll give you from that perspective, because we were way early for the market. There was no availability of high voltage batteries or motors at even in 2020, for that matter, in India. It was very difficult to find a local manufacturer. So we've been interacting with all kinds of vendors from China to Europe or everywhere. So how the whole journey took us to a level where we ultimately developed a Indian motor or an Indian battery is that when you interact with a Chinese vendor, when they sell your battery, they will tell you that they can do everything for you. They will do this, they will do that, and once you make the payment, the battery comes here, the motor comes here. Then when they sell you, this talk in English. When they ask you, when you ask them for service, they talk in Mandarin. So you understand how it is. So you need to really,
Very true. Very true. That's
realize
I've
that.
seen that.
Yeah. So we need to realize that very early, and it's not. See, and also we need to accept that there are some limitations in India. We do not have some raw materials. It's not about just talking about assembling imported parts in India. It's about owning the engineering. So when we developed the electric tractor, we went into the basics of what exactly the tractor needs. We understood how the engine works, and then reversed it to making the electric powertrain. So that is very critical, because not every country, even though they have batteries or motors, will understand the Indian conditions. So if you understand that part, I think that is sufficient for us to start building something local here. Our batteries, so for example, BMS is something that you can definitely own locally or make it right away by understanding the product. When it comes to motors, motor design can be defined by our engineers here. So instead of government banning any import abruptly, it has to be a gradual process. Government needs to talk with the industry as to what is now the industry aware about, what is the capabilities here, and what is the capability of engineering engineers here which are coming up slowly. So we need to be hand in hand with the whole ecosystem, and it's not something that you can just do by cutting off all the imports of cells or raw materials. It needs to also start in colleges, in institutes, universities, wherein you need to really introduce certain courses or expertise development, that programs that can be really critical at this stage, because now we have enough electric vehicles on ground. We find it difficult to hire people who understand EV, and how to manage EV when it's on the field. So that also needs to be done. It's not something that you can just do by stopping imports abruptly. So the entire ecosystem has to change, and it will do so because our environment, as I said in the previous questions also, it's totally unique. Indian environment, we have so much demand, and automatically there will be companies who will develop something unique to this particular space. And in fact, we used to interact with Chinese people earlier, when we used to be on video and on the farm. They used to sit, out on the edge of the chair and literally note down what we are talking about. So when we developed our Indian battery or the motor, it is not just about placing an order and getting a PO and making the payment. It's about co-development. You need to share exactly what the product really needs, specifically, and co-develop it. The software has to be owned by the OEMs, designed by the OEM engineers who have been on the field and seen what exactly and how exactly the product reacts. It's not a straightforward order that you can place for most of the vehicles. Even I think two-wheeler, Mr. Anshu also will agree that the conditions, the way the people use two-wheelers in India versus outside, and I mean, you can see the potholes that we have to deal with. You can see the
Yeah,
floods
yeah.
situations that we have to deal with. It's not normal. So we need to understand that and design products accordingly, and then the
Yeah.
localization will automatically happen. And I think India is more than capable to do that. We should not, just talk about the limitations of the raw material that we have. Raw materials will automatically come if you have the expertise to develop the product here.
So, I'd like to add to what Costa just said. I fully endorse what he's saying. I mean, I think Ola Electric is a good example where they just got technology from Europe and they tried to just copy it here, and it didn't work because Indian conditions are so different, and that's why all those initial quality problems came in. So yes, we have to design and localize the systems for Indian weather conditions, Indian road conditions. I think, but when the question was also about the OEM adoption. So I think OEMs, there's a very clear thing. They're always driven by volume. So we are in touch with some of the largest OEMs who are tier one suppliers to the Tatas and the Marutis, and they have a very simple equation. Once you hit a critical volume, that's only when they'll start gearing up for major investments in this ecosystem. Now, there we are seeing another interesting sort of problem. We went to Ashok Leyland. We were invited and we had a long meeting with their senior management, the chief technology officer and the senior vice presidents. They showed us, their electric bus, which obviously is a switch mobility bus. They showed us a fuel cell bus, which was currently under development. They also showed us a hydrogen combustion bus, which was again a work in progress. And one of the things that I think most companies are dealing with today, like I said earlier, is that it's moving so quickly that they're not sure on which technology they should really bank upon. So should you think of like when Ashok Leyland, I asked you, which technology are you looking at? They said that ideally we'd look at hydrogen combustion, because combustion technology is what we have perfected over the last 70, 80 years, the internal combustion engine. So that is where our forte is. But of course, we have no idea. So that's why we're working on all of them, right? But the challenge is that, when you have uncertainty, then there is always that risk reward paradigm that kicks in. So it becomes a vexing issue ki wo electric pe hi, should they put all their eggs in the electric basket or the hydrogen combustion basket, because green hydrogen is also becoming big, and Gadkari ji is already kind of given incentives on that also. So I think it's a innovation itself is sort of preventing the commercialization, in my opinion. It's a catch-22 problem, but I think the way to break this is that the government, like it stepped up earlier with the EESL scheme, where they ordered 10,000 electric cars from Mahindra and Tata. They need to order, they need to create the marketplace where there's a government stepping in and saying, okay, we'll buy, let's say, 100,000 electric tractors and we'll deploy it at various districts across India, for example, just as a demo. that creates a sense of that creates a marketplace, and that automatically activates the entire ecosystem. Again, economics is what the driver is, right? So until that happens, we'll never be able to break, or it'll be very time consuming for us to really break out of this logjam where innovation itself is at such a fast pace that we are not sure on what technology we should really put all our eggs in, right? All our money in. And in fact, that this is coming directly from one of the large OEMs.
That's true.
Yeah. Yeah. So, Mr. Anshu, that brings to my next question. As IEX Energy moves from pilot projects toward large-scale adoption of retrofit solutions, what is your vision for the company over the next 3 to 4 years, and which markets, vehicles, segments?
Sure. Certainly, my okay. So basically, so what we are looking at is that we are already seeing very good traction now in terms of companies looking to adopt electric vehicles in the supply chains. I think after the two-wheeler, three-wheeler penetration, companies are now looking at bigger vehicles, because for them, sustainability is becoming something that they now need to report in their annual, reports to the government. So I think there is some traction that we are seeing in that aspect. But still, what we feel is that a lot more needs to be done. Like I said, government needs to level the playing field between a brand new electric vehicle and a electric vehicle. We emulate the concept of a circular economy, where the concept of reduce, reuse, and recycle is what the core essence is, and that's exactly what we are doing by retrofitting an electric vehicle, right? By retrofitting a ICE vehicle. So there, if the government can start giving incentives, if the regulatory bodies can start giving a broader permission. So if we are looking at a Tata 407, then anything within the 10% gross vehicle weight, can automatically get certified also, will really help push adoption. Because what happens is, we go to a customer, he says ki sir mere paas Tata nahi hai, mere paas Eicher hai, so can you do this? So again, we have to go for extension of a type approval, or from the ARAI. So these are things which create obstacles and stumbling blocks, which really need to be fixed. And then of course, in terms of cost of certification, the time that it takes to get these things certified, it is very frustrating sometimes. And we are really hoping if government can streamline that, especially for smaller startups, I think it will really help in the adoption, or in the move for people to move towards electric, right? Because what we believe as a company is that the EV transition is not just about new electric vehicles; it's also about converting the millions already on the road. So the next 5 years, I think we are quite optimistic. We are already seeing a strong order book coming in from some selective companies, Dabur, ITC being the two that come to mind, because they have strong policies, internal policies, which are governing this decision. But a lot of the other corporate steel, and I know steel and cement are again doing rapid adoption for electric, because they have to comply with certain norms for the European market. So in that, electric supply chain is something which is important. So I think, again, driven by policy by the government, I think we will slowly see improvement in the adoption, which is already happening, for example, in the passenger vehicle segment that you can see.
Thank you, Anshu. Kaustubh, as we are in the last level of our panel, my very last question to you to conclude this panel is, as Autonext expands its electric tractor technology and works toward wider adoption of electric mobility in agriculture, what is your vision for the company over the next 5 years?
Right. So at AutoNext, we have stopped comparing ourselves with comparing the electric vehicles with diesel vehicles. That debate is already over. The real competition today is between a good electric tractor and a great electric tractor. The companies that will win going forward won't necessarily have the biggest batteries. They'll be the ones that convert every kilowatt hour into the maximum amount of productive work. That's what we've learned. And as far as our vision is concerned, we want to become the synonym for material movement equipments which are used inside industries. Such as like when you call a JCB, it's the first thing that comes to your mind is construction equipment. So similarly, for any material movement, we are aiming to be the one-stop solution, wherein be it a loader, be it a agri movement vehicle or anything. I mean, it's even a forklift. So we have all lineup of products that we have already launching. We have the 45 HP already running successfully. We won the last year's electric tractor of the year award. Now we are launching a couple of more bigger and smaller models as well to completely finish the range of tractors that are typically required in India. So it's a long journey. It's going to be a long journey, but then I think electric tractors, as far as they are concerned, adoption will be much faster because everybody who buys an electric tractor, they are having a business mindset. They buy it for making money and not just for parking it in the garage. So that's our target. Hopefully, it will by 2030 we should be able to cross that 50% mark and cross it over, just like the electric three-wheelers have already done it.
Thank you, Kaustubh. So with this, a heartfelt thank you to our distinguished panelists, Mr. Anshu and Mr. Kaustubh, for an engaging and thought-provoking discussion on building India's EV infrastructure. Your diverse perspectives, practical insights, and forward-looking ideas have shed light on the opportunities and challenges shaping India's electric mobility journey. We truly appreciate your time, expertise, and an invaluable contribution to this meaningful conversation, and I thoroughly enjoyed moderating this panel. Thank you so much for your participation.
Thank you so much. We had a great time.
Thank you.
Thank you.
Thank you to all our distinguished panelists for an engaging and insightful discussion. We now move to a special video presentation featuring Mr. Vinkesh Gulati, Chairperson, Automotive Skill Development Council. His message highlights the importance of developing future-ready talent and building the skilled workforce required to support India's rapidly growing EV ecosystem. Now, I request the audience to please enjoy the presentation.
Good morning. Good morning, everybody. It's great to be at the Electric Vehicle Auto Summit 2020. It's a great platform, and I'm happy to be here representing Automotive Skill Development Council. So India is not choosing between renewable energy and electric vehicle. It must integrate both to build a low carbon economy, and that is how we are going ahead. As of today, we are thinking of electric vehicle. We are also planning hydrogen, and there would be many more alternate fuel which will come in the which our research scientists are working on, and hope they'll be able to deliver soon, and the manufacturers will be able to make it an economically viable product for India. So coming to electric vehicle, which is today the need. So it needs electricity, and to deliver the real climate change, we have to see that whole process of that is renewable or better and doesn't lead to additional carbon. So we have to see how we can purely shift to solar energy or any other renewable or wind energy, how to charge the electric vehicle so that it totally moves out of adding carbon things and all that. So India EV transition has moved beyond early adoption and is now entering an early scale-up phase. And I'm happy to say the percentages, the ratio of two-wheeler EV being registered is increasing year by year. It's now more than 10 or 12%, and even cars are increasing, which is a very good sign, which shows that customers' adaptability is increasing. So one major, I'll not say hurdle, but a challenge is the transport sector, because to decarbonize that, it's a big challenge because of their load carrying and the long distance they do. And everything today is heavily based on the imported crude, which is used for diesel for these vehicles. No doubt, the small commercial vehicles are shifting to electric vehicles, but the higher ton vehicle is not able to do that. There has been a lot of trials with hydrogen and all that, and on-road working is going on, but still it's far off. So can we use electric batteries to run the transport vehicle? That's where we have to see, because there are challenges of idle trucks standing because of charging or battery draining out, and on a long distance where they are not able to get charger. But yes, we'll have to work towards this. And EV charging, as of today, on the highways and major areas is more on coal heavy base, which has to be shifted towards renewable energy. So India's clean power base is expanding, with non-fossil capacity already crossing the 50% share mark in installed electricity capacity on the charging side. However, grid bottlenecks remain a real issue. India curtailed 300 GWh of renewable energy in Q1 2026 because of transmission constraints. This means the country must expand generation and grid flexibility at the same time, especially if EV demand rises quickly, which we are looking at. Like I told you, the EV growth is in a right stage as of now. In June 2026, the electric vehicle retail sales hit an all-time high of 306,000 approximate units, up 63% year on year. And that's a huge growth, where the industry is growing around 15-20%. And EV penetration crossed 12% for the first time. This makes EV one of the most visible growth stories in India, energy and mobility transition. Over the last 12 months, from last year, July 25 to June 26, India has recorded 28,27,000 EV sales, excluding the low-speed e-two-wheelers, which are not registered. And obviously, their usage is very limited in a kilometer area or in a geographical area. So, giving you a deeper study, the two-wheeler remains the largest EV volume segment. But if I talk about the three-wheeler, is actually the highest in ratio. So three-wheeler has already crossed more than 60% of electric vehicle as compared to ICE, whereas two-wheeler is also behind the second most better category in EV adoption. And passenger vehicle is also doing great. It has already crossed around 32,000 units, and it's doubling year on year. And the way the OEMs are coming up with great EV products, I am hopeful that this will grow further. And in this whole process, there are states like Delhi and Haryana and UP who have come up with a very good EV policy, which is helping us increase the adoption. Delhi has also come boldly and said that they will not register three-wheeler from next year and two-wheeler from another 2 years down the line, ICE product, which means the full range will become EV, which will help the environment. And you know, Delhi comes under some of the top polluted cities, and I feel that is the needed. So hats off to the Delhi government to take such a bold decision. There is one thing which is still a challenge, like I told you, the transport department. The other challenge is the buses, the public transport. But happy to say, a lot of departments, the state departments are shifting towards EV. No doubt it's still a long way gone, but they're already in H1 2026, there is around 3,000 odd buses registered, electric bus registered for public transport. And a lot of other companies like JPM, Tata, they are coming up with a system where they are putting in the capex and running the show, which means the efficiency increase, the vehicle's reliability increase, and the maintenance also improves. So why does this all matter? This is a point where this we have all gathered to understand. So the EV shift is not about one category, two-wheeler or three-wheeler or something else. It's basically now the part of the mobility story. It's not an additional fuel. It's now become the most important fuel or most important energy to run the vehicle. This matters because the transport impact depends when EV adoption moves beyond short distance urban vehicles into higher energy use category. EV growth at this scale makes charging infrastructure, grid planning and renewable linkage much more important than before. And that is where, as of now, the government is working, the OEMs are working, the dealers are working, because slowly and steadily, every dealer is installing a fast charger at their location wherever the permission is given. And even OEMs are supporting by installing fast chargers on their own, on the highways, at the major public area where vehicles stop for maybe a transition for a fuel or something to eat something. So India has already reached 297.36 GW of non-fossil electricity capacity and 288.58 GW of renewable capacity. This was by 30th June, crossing the 50% like I told you before. This is important because cleaner grid improves the environment value of EV. And we look forward to this percentage going up, but no doubt the demand is also going up for the normal electricity things also because of the environment issue of heat and all that. But let's hope that we are able to faster improve non-fossil energy to support the government, support the environment. So India's public charging network expanded from some 5,200 odd unit stations in 2020 today to 26,367, and lots are going on. So the slow pace is now increasing. I feel we'll be adding around 10,000 stations every year as now dealers, OEMs and public and these startups have come to support us. So this is growing, but scale of vehicle adoption is still faster. We have to see how this can be implemented. Like some governments are implementing for the apartments to have it, offices to have it. This will all support. So everybody who is building up a factory or a housing unit, they have to have this so that it supports the adoption and the infrastructure improves. So EV should be presented as a flexible demand, not just as vehicle. Smart charging can shift load to hours when solar and wind output are high. And like buses, they are already depot charging and all those, and those will be great. After giving such an important inputs on EV, environment, infrastructure, now the main challenge becomes putting in capex is very easy. You have money, you can take a loan and you can start it. But how to maintain it, how to operate it, and that is where Automotive Skill Development Council comes in. The EV transition is not only about infrastructure, but also about skilled human capital. India currently faces a 40 to 45% skill gap in EV-related roles. Annual demand is rising at 30 to 40,000 trained professionals across installations, maintenance, battery systems, and diagnostics. At ASDC, we as an apex body are mandated to skill, upskill, and reskill, and sometimes unskill also the automotive workforce in alignment with the industry needs. So we have focused approach. We have a lot of QPs on this. We support the EV manufacturing and servicing, charging infrastructure installation and maintenance, battery technology and diagnostics. All these by many course curriculum which we do, where our training partners support the people who are interested to get skill to take those skilling and use for their jobs. I request everybody who is in the audience, anybody who is interested to open a skilling center or work for it, please get in touch with ASDC and we'll try to support how we both can make a win-win situation for this EV transition. So there are a lot of qualifications, like I told you, to name a few: EV charger technician, EV infrastructure installer, battery service technician, and obviously the vehicle service technicians and support wala. And this all done. And as per us, the future demand, we'll need at least 2 lakh skilled EV professionals by 2030. Training investment in the EV ecosystems are projected to cross around 13,000 crores. And this is what we think today. If the adoption grows way high, this can also go up, which means this is a big industry coming up for you to invest and earn. ASDC is aligning with the national priorities to support a large-scale EV scaling ecosystem under Viksit Bharat 2047 vision. Do join us if you are interested in that, because I know everybody here is interested in the EV journey. Maybe skilling can be the call which you were waiting about. So talking about what's the future. So like I told you, we need so many manpower. We need so many charging infrastructure. So like ultra fast charger, 120 to 300 or 350 kilowatt, battery swapping ecosystems, vehicle to grid integration, and some discussions are also happening how we can have highways which can charge. No doubt it's a dream today, but there is a research, there is a working on it. And obviously then the power infrastructure upgrades, not upgrades only for fossil or non-fossil, overall upgrade. We need more electricity. If it is non-fossil, it's better. There are a lot of renewable energy where we can do that. And this has to, the EV ecosystem is expected to be there 1.2 lakh crore by 2030, with charging infrastructure contributing nearly 50,000 crores. This transition presents both a clean energy opportunity and a massive employment engine. So there are a lot of challenges, but let's not talk about challenges. These are the opportunities where we can all work together and take this further. And this is a transition which is better for everybody, better for environment, better for government, better for Indians, us humans, and better for entrepreneurs also, as a startup, as a businessman, even for people who want to do job here. A good employment opportunity where AI won't take your job out. This is a job which you have to be skilled to do it, which means no competition from AI. So next phase of the EV industry is not simple. It is obviously vehicle sales. Then it is actually smarter power to mobility integration. The country now has a strong EV momentum, a larger renewable base, and rapidly growing charging infrastructure. The challenge is to connect all three into one and make this feasible, successful, and supported to make it net zero as per our how our Pradhan Mantri Modi ji wants to reach in the future destination. Let's all come together and make this transition smooth and beneficial for all of us. Thanks for having me here.
इंडिया के ऑटोमोटिव सेक्टर का फर्स्ट स्किल डेवलपमेंट काउंसिल, ऑटोमोटिव स्किल्स डेवलपमेंट काउंसिल ASDC, हम दिलाते हैं देश के युवाओं को अच्छा काम, नाम और पहचान भी। CM, ACMA, FADA और NCVET के सपोर्ट से ASDC हर साल लाखों बच्चों को उनके विकास के लिए लेटेस्ट टूल्स, ट्रेनिंग और प्रैक्टिकल एक्सपोजर देता है। इंडस्ट्री रिक्वायरमेंट्स को फुलफिल करने के लिए ASDC ने रोबोटिक्स एंड ऑटोमेशन, इंडस्ट्री 4.0 टेक्नोलॉजीज, इलेक्ट्रिक व्हीकल टेक्नोलॉजी, ऑटोमोटिव सस्टेनेबिलिटी एंड सेफ्टी जैसे प्रैक्टिकल ट्रेनिंग कोर्सेज इम्प्लीमेंट किए हैं। हमारी CSR योजनाएं युवाओं को अपस्किल और रोजगार दिलाने के लिए बनी हैं। हमने हीरो मोटोकॉर्प, टोयोटा और महिंद्रा जैसी कंपनीज के साथ पूरे इंडिया में ट्रेनिंग सेंटर्स डेवलप किए हैं। ऑटोमोटिव स्किल्स डेवलपमेंट काउंसिल, नई सोच, नए हुनर का एकमात्र प्लेटफॉर्म। ASDC।
Thank you for the beautiful and inspiring presentation video. As we are moving forward, as EV adoption continues to grow, the success of this transition will depend not only on the better vehicles but also on the smart charging infrastructure, resilient power grids, renewable energy, integration, and social digital ecosystem. This session will explore the technologies and the strategies required to make the large scale EV adoption both practical and sustainable. It is my pleasure to introduce our esteemed panelists. First of all, Mr. Abhay Soman, Director Strategic Partnership and Growth, India and Southeast Asia, Dana TM for India. Secondly, Mr. Shivam Sisondia, Co-founder and CEO of Bridgelight. Third, Mr. Jhumarmal Pannaram Tuneval, Chairman and Managing Director, Tuneval E-Motors Limited. And last but not the least, Mr. Engineer K. Ravikant, the Assistant Professor of CAC Department, Aurora, deemed to be University, Hyderabad. Moderating today's discussion is Mr. Vishwas Das, Account Director, Seraphim Communications. Please join me in welcoming our distinguished panelists. And before starting the discussion, I would like to request my audience to be ready with their questions. We will take all their questions after this session. Now, I would like to my panelists to come on the stage and start the discussion.
Thank you so much. It is my privilege to warmly welcome our distinguished panelists to the stage, starting with Mr. Shivam Sisodia, Mr. Ravikant, Mr. Abhay Sonam, and Mr. Jhumar Lal. Thank you for joining us today. We look forward to an insightful discussion as you share your expertise and perspectives on shaping India's EV charging infrastructure and building a grid-ready ecosystem for the future of electric mobility. With
Yeah,
this,
good morning. Good morning.
good morning. With this, I would like to begin with Mr. Shivam Sisodia. Thank you so much, Mr. Shivam, for joining us. My first question to you is, Bridgelight has worked closely with electric mobility users. Where do you see battery swapping outperforming fast charging, and where does fast charging remain indispensable? Over to you, Mr. Shivam. Mr. Shivam, can you hear me? So meanwhile, what I can do is I can request Mr. K. Ravikant. And my question to Mr. Ravikant is, how can AI, machine learning and data analytics be integrated into battery management systems to accurately predict battery health, remaining useful life and potential safety risks? Over to you, sir. Professor Ravikant, can you hear me?
I think some challenge. Can you hear me? Vishwas? Hello, this is Abhaya. Can you hear me? Because I think
Yeah, is it Mr. Abhay? Mr.
Yeah.
Abhay Soma? Yeah. So, Mr. Abhay, since I think meanwhile they are figuring out the solution to come
Yeah.
on camera.
The others,
Yes. Thank you for joining us. And I want to begin with you. And my question to you for this panel discussion is like, how high power DC fast charging is becoming the global benchmark. How do you see ultra fast charging evolving in India over the next 5 years?
Okay. First of all, I would thanks for the opportunity, and I will welcome all of the panel members. And I will start with a very good news for the group. So I don't know whether you have seen yesterday's minister's speech in Lok Sabha, and he announced yesterday that a year back we had about 39,000 chargers, and last year the charger numbers have gone to about 52,000 charging facilities. And so in terms of vehicle density, charger density, earlier it was one charger to 250 vehicles in India. And within 1 year, it has gone to one charger to 175. So there's almost improvement of almost, I would say, 30% in 1 year. And going forward, definitely the aim of government is to go to the best class. This thing is 1:25 as per China, Norway, and other big countries, big advanced countries. So I would say that's a good news to start this session. And I'm hoping to have continuous improvement in charging infrastructure in coming time. So coming back to your question on the fast charging, definitely I'm coming from motor industry where we supply electric motors to various two-wheelers, three-wheelers, as well as buses and trucks. So there are few chapters that are this thing. One important is the use of silicon carbide. Because as we have already seen the substantial benefit when we switch over to silicon carbide inverters in power supply, similar to for DC fast charging. Semiconductors play a major role, and with silicon carbide, your charging time can come down by almost 50%. So presently, the fast chargers 150 kilowatt, they take about 40 minutes, 30 minutes to charge the vehicle. Against that, once the silicon carbide inverters with the high powered module charging infrastructure, the charging time can come down and it can go up to 300 kilowatt, 500 kilowatt. So that I would say very, very good, and that's the trend I'm seeing. Right now, I would say the majority of the chargers are smaller capacity for the two-wheelers and smaller cars, where the batteries are also very small. But going forward, the trend is definitely to go for DC fast chargers up to 300 kilowatt or even megawatt charging, like for the trucks and buses. So I would say that's the trend we see in coming years.
Thank you, Mr. Abhay. I would like to move on to Mr. Ravikant. I can see that he has joined. Mr. K. Ravikant, if you can hear me. Are you able to hear me?
Yeah.
Yeah. So my question to you is, how can AI, machine learning, and data analytics be integrated into battery management systems to accurately predict battery health, remaining useful life, and the potential safety risks? I would like you to answer this question. Over to you.
Very good morning, all. Thank you for giving me the opportunity. So basically, I belong to the team of artificial intelligence and machine learning, and I think this was something right question from the panel members too. See, what I personally feel like as on date, like artificial intelligence or machine learning or data analytics, all these technologies will definitely enhance the battery management system. Because we have continuous analyzing real-time batteries where the data such as with respect to the voltage or maybe the current or maybe the temperature, the charging cycles, the vehicle internal resistance. So we have a system where we can monitor it. And we do have machine learning models which can learn this data based on the battery degradation patterns and provide the accurate estimation, maybe say like the state of health or maybe the remaining useful life of the battery, or maybe it detects the early signs of faults such as overheating or maybe the thermal runways. And even ML will also enable us to predict the maintenance and also optimization of the charging system. And it also helps in improving the battery safety life. I can also quote an example of the Tesla vehicles, which actually uses an AI-powered BMS system to monitor the battery performance in the real-time scenario. And the systems will also predict the battery degradation. It optimizes the charging behavior. It also alerts users what the potential issues. It even gives the failure errors. So I think it improves the safety measures of a common. Hope I have justified your question, please.
Yeah. Thank you, Mr. Ravikant. Mr. Shivam, I would like to ask one question to you. Bijli Ride has worked closely with electric mobility users. I'm more keen to understand where do you see battery swapping outperforming fast charging, and where does fast charging remain indispensable?
I think we are not able to hear.
Oh, okay.
Can you unmute yourself?
So at Bijli Ride, we have always believed that there's a single solution for every EV use case. Different users have different needs, right? And battery swapping performs exceptionally well for commercial application like food delivery, quick commerce, bike taxi, and where every minute counts, right? And on the road directly, where every minute counts and it directly impacts their earnings, right? A delivery partner cannot afford to wait for 45 minutes or 20 minutes or for 4 hours, like if it's slow charging, right? So they want to swap a battery under a minute and go. And fast charging, on the other hand, is more suitable for private vehicle owner, or who is typically charged while at home, at work, or during planned breaks. It also becomes important for electric users and long distance travel, where battery swapping is still evolving, right? And we have seen that commercial riders prioritize uptime over anything else. For them, the battery swapping is just not a convenience, but it's a necessity. It's a business necessity, right? So it doesn't outperform. Both has different use cases, right? And if you see the gig economy, they're more towards the swapping, and the private vehicle owners, or as I mentioned, like private vehicle owners, or someone who who just want to charge, who just want to go for a ride, like is fast charging is beneficial for him.
Thank you, Mr. Shivam. We have with us Mr. Jhumarmal Tanwalji as well, who is a chairman and managing director of Tanwal. Jhumarmalji, if you can hear me, my question to you is, as an EV manufacturer, what expectations do you have from India's charging infrastructure to accelerate customer adoption? Over to you, Mr.
Thank you. ईवी चार्जिंग मैन्युफैक्चरिंग के लिए अभी इंडिया में एक बहुत बड़ा चांस है। अभी बहुत सारे चार्जिंग स्टेशंस लगे हैं, बट जो अभी जो लगे हैं वो आप एक ऐसा समझ सकते हैं कि 10% ही लगे हैं। और जितने अपने पॉपुलेशन है और जिस टाइप से ईवी अभी डेवलप हो रहा है, तो उसमें चार्जिंग स्टेशंस लगने अभी बहुत बाकी है। उसमें मैन्युफैक्चरिंग में अभी अपने पास इतने इंडस्ट्रीज नहीं आए हैं जो यहाँ पे बना के और उसको इंस्टॉलेशन के बाद में उसका एएमसी और उससे बड़ा
Welcome. This webinar is being recorded.
पास सोलर पावर का अच्छा सोर्स है, तो उसका मल्टी यूज होना चाहिए। और चार्जिंग स्टेशन में भी जहां पर पावर अपने को सस्ती मिल रही है, इनपुट पावर अगर सस्ती मिल रही है, तो उसका कहीं ना कहीं मार्केटिंग भी होना चाहिए। कि जैसे अभी बीपीसीएल है, वो 14 रुपीज पर यूनिट से सेल कर रहा है। अदर कंपनीज आईसीएल 16 रुपीज से सेल कर रहा है। अडानी 25 रुपीज पर यूनिट से सेल कर रहा है। तो कहीं तो उसका भी एक ऐसा मार्केटिंग होना चाहिए कि भी हमारे पास इतने में हमारे ऐसा है ना, कंपटीशन होना चाहिए। जैसे जैसे कंपटीशन और इसका मार्केटिंग बढ़ता है, लोग ईवी सबको चाहिए। जस्ट डर क्या है, उनको चार्जिंग कहाँ पे करेंगे और उसकी कॉस्ट क्या रहेगी और उसका बाद में क्या एक्सपेंस, यानी ये अपने को कॉस्ट इफेक्टिव रहेगा या नहीं रहेगा। तो इस चीज के ऊपर आई थिंक मुझे फुल कॉन्फिडेंस है कि गवर्नमेंट इसके ऊपर बहुत सारा अभी काम कर रही है, अवेयरनेस भी ला रही है और तरह तरह की स्कीम भी लेके आ रही है, इंसेंटिव का भी लेके आ रही है। पर बहुत सारे एसएमईज कंपनी तक वो पहुंच नहीं रही है, या जो ईवी चार्जिंग स्टेशन में कोई बिजनेस कर रहा है वो बिजनेस में ही इतना बिजी है कि वो स्कीम और वहां तक पहुंच ही नहीं पा रहा है। तो मेरा व्यू ऐसा है कि इसमें अभी बहुत बड़ा बिजनेस है, तो मैक्सिमम इंडस्ट्रीज को इसमें आना चाहिए और फ्यूचर का एक बहुत बड़ा ये बिजनेस है, जिससे अपने कंट्री को एक बहुत बड़ा बेनिफिट मिलेगा। और जो ईवी कार्स ये जितने भी ला रहे हैं उनको एक बहुत बड़ा सपोर्ट मिलेगा, क्योंकि ये सभी की जरूरत बनती जा रही है। यस सर, थैंक यू।
जी, आपने बहुत वैलिड पॉइंट बोला और मैं इनफैक्ट एक स्टडी भी देख रहा था, उसमें आई यूजुअली डू इंडिया वर्सेस चाइना कंपैरिजन। तो उसमें मैंने देखा कि वाइल चाइना ईवी इंफ्रास्ट्रक्चर और नंबर ऑफ व्हीकल, दैट पोर्शन revolves around 50 to 55% vis-a-vis India's 5% to 6%। तो अभी एक बहुत ह्यूज डिफरेंस है। और आपने जो एक बात बोली, बहुत ही वैलिड पॉइंट बोला कि जो ईवी स्टेशंस की जो प्राइसिंग है उसकी मार्केटिंग बहुत एग्रेसिव हुई है, सो दैट जो हमारे यूजर्स हैं उनका एक जो डर है कि ईवी ले या ना लें, क्योंकि इंफ्रा पूरा है नहीं थ्रू आउट इंडिया। तो यू हैव रेज्ड अ वेरी वैलिड पॉइंट। एंड नाउ दैट ब्रिंग्स मी टू माय नेक्स्ट क्वेश्चन टू मिस्टर अभय सोमन। Soman, I would like to ask you about what charging standards should India prioritize to ensure compatibility with global EV manufacturers? Over to you.
Okay. As you know कि सब जगह पे अलग अलग चार्जिंग इंफ्रास्ट्रक्चर था। So like Japanese we are having different standards, so they have different distinct NACS standard है, CCS2 chargers है। So these are the few I would say charging types है। So particularly I will talk about the heavy industries because two-wheeler, three-wheelers I would say बहुत सारे लोग घर पे ही चार्ज करते हैं। टू व्हीलर का एक स्टडी देखा मैंने, इवन फोर व्हीलर्स का, I would say 70-80% of the use cases they charge the battery at home, means at घर पे चार्जर लगाते हैं पार्किंग के एंड आपका चार्जिंग हो जाएगा। तो your requirement on road charging is much less compared to your in home charging. So that is the first thing. Second thing is this is required more for the heavy duty trucks and buses, so which market as of today is very low. The penetration is hardly means buses का अच्छा है because those are all fleet owners and fleet state transport, But trucks is now the emerging where the CCS2 charger, I would say this is more important. And that's what, hello? Hello?
Yeah, please carry on, sir. We can hear
You
you.
are audible.
Okay. No, I can. There was a video disturbance. Okay. So that's the way. So I'm saying CCS2 kind of chargers which can be standardized across all platforms and all trucks and buses. This thing that would be very good. And because that will give the standardization. Because ultimately, जो साहब ने बोला वैसे correct है. वो market अभी very छोटा है. But as we grow, there has to be standardization of all types of even chargers, all types of systems. And even the software or even the compatibility between the two chargers, so that is most critical. So वो हो जाएगा तो automatically आपने बोला वैसे कि there definitely will be some competition because every charging station he has to sell more energy to customers, and then they will start advertising. I can give you a rate of say 10 rupees per unit, or someone can say 12 rupees plus additional facilities, some recreational facilities. By the time this is taking place, say half an hour, if the vehicle is charging for half an hour, then they can offer some snacks and these things. So there are so many things. So that's the kind of definitely we want in India. And with that charging standardization, our infrastructure will automatically grow in many folds in coming years. That's what I think is the right way. But standardization is must, absolutely.
Right. I totally agree with you, Mr. Sohan. That brings to my next question to Mr. K. Ravikant. Mr. Ravikant, I would like to ask you more about the AI-driven battery diagnostics. So the question is, what role can AI-driven battery diagnostics and predictive maintenance play in improving the reliability and reducing the life cycle cost of EV batteries? Over to you, Mr. Ravikant.
Yeah. As the panel members were also discussing, so most often as I rightly addressed on the AI technology. So as of today, like AI-driven diagnosis is continuously a monitoring system where in order to check the battery performance, or it will also identify the abnormalities before some failure occurs in the vehicle. And today it's a big challenge, like how we predict this battery system, because the maintenance schedules, or maybe the problem with servicing of the batteries, or maybe the replacement of the battery. So, there must be some system where we can actually check and fix the problem in a regular intervals of times, which is happening with all the industries. And I also tell, like, this will also reduce the unexpected breakdowns in the vehicles, and it will also extend the battery lifespan. And compared to the existing ones, it also minimizes the maintenance cost. And I can also conclude saying, like, it improves the overall performance and also the vehicle reliability of the system. Let me also give you an example, like the BYD employees also uses this AI-based battery monitoring system to detect the abnormalities with respect to the cell in early stage. And what happens is this enables us the timely maintenance, it reduces the battery replacement cost, and also improves the reliability over the electric vehicles, not only the four-wheeler, even the electrical buses, even the passenger vehicles. So we can even apply this diagnosis system and also help the predictive maintenance of the entire e-vehicles. Over.
Thank you, Mr. Ravikant. Shivam, you earlier spoke about battery swapping, outperforming fast charging. So my next question for you is, like, can battery swapping and fast charging coexist? That is a very important and valid point, given that the EV adoption rate is going up. So can battery swapping and fast charging coexist, or will one eventually dominate? Will one eventually dominate the market?
Right. Okay. So I don't think there's a battle, right, where one technology wins, the other tech loses, right? As sir mentioned, like many people charge at home, right, where it's convenient for them, right? Currently, as as mentioned again, there are only less than 6 to 7% charging infra as compared to what China had or what the requirement is currently, right? And Indian mobility segment is too diverse for a single charging model, right? And as it depends, the charging rate will vary. Like if you charge at home, it's just hardly 5 to 6 rupees per unit, and if you charge at Adani, it's like 45 rupees per unit or per kilowatt they're charging, right? So battery swapping will continue to dominate high as part of high utilization because people look at for more utilizing the vehicle in terms of commercial fleets where vehicle runs throughout the day, and fast charging will continue to grow on the personal mobility and a premium EV segment, right? And it is similar to how we differentiate the fuel station, CNG station, and home fueling options today, right? The future EV system ecosystem will always have multiple energy delivery models working together, right? So instead of asking which technology will dominate, I think we should have asked how we can make both the technologies accessible and affordable for users, right? So the question is how accessible uh, the energy will be. And on the one side, we're talking about swapping. It's more commercial, right? As we have understood so far, two-wheelers, three-wheeler autos, right? They all are using, and it's about the utilization, right? If they don't utilize, they won't be able to pay, right? They won't be able to survive, right? So yeah, so like we should more focus on the utilization and accessibility and affordable for users.
Yeah.
Affordability is on top because in charging also it makes more sense for a user in India currently to charge at home because overnight you can just put it on charge and like it'll get charged, right?
Right. Affordability is very
In
pertinent.
China, maybe home charging is not an option. That's why they have more charges, right? And not is an option, but since we can see like in buildings or sometimes the parking issues are there. In India, we have like home, just charge at home.
Right.
Also, one quick thought on that. As we discussed on the charging, yes, definitely both will coexist. And on the home charging front, also it adds to the, I would say, the balancing of grid, because the load at night is much lesser compared to the day load. If you look at the pattern, the peak load happens during the day when all air conditioners, all factories are running in full speed, that the power requirement is maximum. And if you look at the night time, yes, the load is always come less because of the temperature. And also the rate of electricity is also much lower compared to the daytime. So if you look at that, and that's the rate, that's what. So if you charge at night, automatically it will also help the various grid and the operators to balance their requirement, so that you will have more uniform power requirement rather than going up and down very drastically. So that also will very helpful for home charging. So I would say that kind of charging, night charging, I would not say home charging, but also night charging, wherever it is possible. So yes, so both will coexist, charging as well as battery swapping. Sure.
Right. I agree with you both with Mr. Shivam and Mr. Abhay. So
Yeah.
Jumarmal sir, आपके लिए मेरा नेक्स्ट जो क्वेश्चन है वो ये है कि जो चार्जिंग स्पीड है, गाड़ियां जो ईवी आ रही हैं उसकी चार्जिंग स्पीड, वो कितना बड़ा फैक्टर है कि वो लोगों को इन्फ्लुएंस करेगा कि हमें ईवी लेना है या नहीं लेना है?
डेफिनेटली सर, अगर स्पीडली चार्ज होती है कोई भी बैटरी, चाहिए कार की हो या टू व्हीलर की हो, तो कस्टमर उससे बहुत सारे एट्रैक्ट होते हैं कि जैसे फ्यूल भरवाते हैं तो विद इन मिनट्स में वो लोग फ्यूल भरवा लेते हैं। लेकिन अपने ईवी में ऐसा है, जितना फास्ट चार्जिंग करेंगे उससे एक तो इक्विपमेंट की कॉस्ट बढ़ जाती है, और कहीं ना कहीं अभी तक जो केमिस्ट्री के सेल आ रहे हैं उसमें जितना फास्ट चार्जिंग करेंगे उसको कहीं ना कहीं उसमें उसकी लाइफ के ऊपर इफेक्ट आता है। तो कस्टमर को वो चीज से कुछ लेना देना नहीं रहता है, वो तो बोल रहा है कि भाई जितना फास्ट चार्जिंग है और इमीडिएटली अपने वो काम के ऊपर लग जाए। तो फास्ट चार्जिंग जरूरी है, बट उससे अपनी कॉस्ट बढ़ती है।
जी सर, इसमें कुछ और भी आप ऐड करना चाहेंगे, जैसे कि रिन्यूएबल एनर्जी या एनर्जी स्टोरेज जो ऑप्शंस हैं, कैसे ट्रांसफॉर्म करने ईवी सेक्टर को?
यस सर, अभी आने वाले टाइमिंग में अभी देखो जो है वो एक अलग एंगल में चल रहा है, लेकिन नेक्स्ट जो आने वाला समय है उसमें स्टोरेज वाला सिस्टम है वो बहुत पॉपुलर होएगा और वो कॉस्ट भी सेव करेगा। जो अपना सोलर एनर्जी है उसको एक बड़े जैसे अभी फ्यूल पंप है, तो फ्यूल पंप की जगह पे वहां पे बैटरी पैक लग जाएंगे, वो एनर्जी स्टोरेज होएगी और वो एनर्जी जो ट्रांसफर करेंगे ईवी में, तो उसकी कॉस्ट भी कम होगी और एनर्जी के साथ में ये सोलर एनर्जी के साथ में विंड है, ऐसा और भी मल्टी ऑप्शंस अभी धीरे धीरे आते जा रहे हैं। तो वो एनर्जी कम कॉस्ट कम होने से कस्टमर भी अट्रैक्ट होंगे। देन बैटरी है, उसको अगर डीसी टू डीसी ट्रांसफर करेंगे और थोड़ा अगर स्पीड कम रखते हैं उसकी वैसे बनी रहेगी। डीसी टू डीसी निकली जाता है तो जो बीच में करंट है वो वेस्ट जाता है, वो कम होगा और डे बाय डे कॉस्ट है वो कम होगी, क्योंकि मेन कम का ही एक टारगेट है। तो कम कॉस्ट में अपन ज्यादा से ज्यादा कितना चला सकते हैं, आज भी एवरी कस्टमर यही कॉस्ट निकालते रहता है। भी आज मेरी ईवी इतना चार्ज करने के बाद में कितना मैक्सिमम किलोमीटर चली।
राइट, थैंक यू जुमा जी। Mr. Abhay, my next question is to you. As charging demand grows, how important will smart grid integration and AI-driven load management become?
Yeah, absolutely, absolutely. In fact, that's what I tried to, I would say, answer some bit of it. So, abhi jo charging infrastructure hai, that is purely based on the grid. So directly, all the chargers are pulling power from the grid. So there is definitely, as the bigger vehicles are being charged and charging capacity goes up, it's like megawatt charging, definitely that's going to affect the grid stability. So more important is the base, that is battery energy system management, because that is must. So any new charging infrastructure, I think government is also working on it. So इसके बाद जो भी नए fast charging stations आएंगे, that will also mandate to have their own battery storage system. So it will not draw all that power directly from the grid, but it will balance it out. So whenever the batteries will be charged during the night or during the low demand cycle, the batteries will be charged, and that power will be used by the chargers, because that is must. Because otherwise, suddenly, if you cannot imagine that there is so many, I would say, millions of vehicles charging at the same time and drawing power from grid, which is practically not possible. And that kind of peak demand, no system can do that. So definitely AI will play a major role in that, how to balance the power requirement within these grids. And definitely the charging infrastructure will be also developed along with the battery system, so that you need not draw all the current from the grid, but it will be drawn through the battery and some from the grid. Again, it all depends on the balancing, how we do the balancing, how the AI will do that, and with the real-time information available. But that is must, absolutely, because without that, it is not going to work. Otherwise, it will be a big challenge for the various state and government grid, how to manage that. Because the demand also will go up, and the other, again, it will be a very, the demand will be much higher in daytime, and night time the demand will be much lesser. So definitely we need those kind of balancing equipment somewhere in the system at the charging stations. Yes.
Right. Thank you, Mr. Suman. Mr. Ravikant, we really see that whenever a new technology is coming, or whenever India is shifting to a new technology, there's a huge role of the academia as well as the technology company. So what are the most promising opportunities for collaboration between academia, tech companies, and the automotive industry to develop intelligent and sustainable battery technologies? Over to you.
I think this question is a little more connected to me. So if you see the future of intelligent system or maybe the sustainable battery technologies, it definitely requires a collaboration. And as you rightly said, academia, the tech companies, even the battery manufacturing industries, and also the automotive industry has all come together. So each stakeholder brings unique strengths, maybe with respect to the universities contributing to the current cutting technologies, or maybe the skilled talent, even the technology companies providing the artificial intelligence, talking about the cloud, talking about IoT, talking about data analytics platforms, will all help the batteries or maybe the e-motors, to automate. The real world testing has to be happened. The manufacturing expertise are also required on the large scale. And let me also give you, this collaborations will significantly accelerate the innovation and reduce the time required to commercialize the next generation battery technology. Let me also talk about a few key areas of the collaboration with respect to, if you talk about AI-based battery health monitoring system. We also have some researchers working on this. They are also working on developing an advanced AI and machine learning model, which will actually predict the state of the health condition of the battery, the state of charge condition of the battery, or the remaining useful life of the battery. And if you talk about the next generation battery material, absolutely yes, the academia researchers can also do investigate on the advanced battery chemistry, such as solid state batteries, or the sodium ion batteries, or the lithium batteries. Okay, there are people working on it. And there are also tech companies who are actually focusing on the smart battery management system, with respect to the IoT sensors used, or the cloud tech computing used, or with respect to the predictive analysis applied on this battery system. There are also, let me also quote some real-time examples from our country. The IIT Madras, I think you might have heard about the collaboration with Hyundai Motors on the electric mobility and battery technologies. And there are researchers working on the battery management system, battery safety conditions, battery charging conditions, even on the AI battery analysis. And to my knowledge, there was a campus from IIT Mumbai working on Tata Motors, on advanced battery research, and also on AI-enabled energy management system. There are campuses like IISc Bangalore working on to this collaboration with IISc, Indian Institute of Sciences. And there's a lot of research happening onto this development of next generation battery system with respect to higher energy density, and the most important is improving the safety mechanism of a common man. See, today we want the trust, and if the companies can give the trust to the common man, I think this EV ecosystem will grow in a next level. And this is what even our government, our Prime Minister Modi ji also wants to see, this ecosystem coming as the next generation. That is what even we all are looking to see, the products coming from making India. Okay, there were days where we were telling made in China, and now we see products coming from made in India, making India, and this transition is required in this automotive energy source. And I think this electric mobility system will definitely improvise, and as rightly said, we need collaboration from academia, industry in a large scale. Yeah.
Right. So this brings to the end of this very enriching and thought-provoking panel. A sincere thank to our esteemed panelists, Mr. Abhay Soman, Mr. Shivam Sisodia, Mr. Jhumar Lal Tanwal, and Mr. K. Ravikant for an insightful discussion on charging infrastructure and grid readiness for mass EV adoption. Your perspectives on expanding charging networks, creating affordable and accessible charging solutions, the growing role of home chargers, effective pricing strategies, and the importance of fast charging in influencing consumer purchasing decisions have offered valuable insights into India's evolving EV landscape. And we deeply appreciate your time, knowledge, and valuable contributions. With this, I would like to hand over the baton to the anchor of this webinar. Thank you so much, everyone.
Thank you.
Thank you to our esteemed panelists for sharing their perspective on the future of charging infrastructure and grid readiness. Before we conclude today's program, let's have one final round of audience interaction. If anyone has a closing question or would like to share a key takeaway from today's discussion, we are delighted to hear from you. And as I can see, there are a lot of questions on my screen. So there is one question for our panelist from the name Sunil Ji. Can you please tell more about cybersecurity standards? Who has to follow them, OEM or auto supplier? Please throw some light on this topic.
Okay, I will just briefly discuss on this. So cybersecurity is a very important subject. I don't know, are you aware of that? So the recent incidents of the three-wheelers in Delhi area, and because with the some Chinese app, they were able to switch off the three-wheelers. So it's a big risk. We recently experienced that kind of risk, and that those can be addressed with cybersecurity measures. And government has already come up with some kind of initial draft notification on cybersecurity, what is expected. And I would say the OEMs as well as the tier ones are already started working. Like as I said, I'm from motor industry, so we supply motor and inverters, which plays a major role in the driving the EVs. So I would say we are already working with our customers, OEMs, and they are also in turn working to establish those cybersecurity protocols in their vehicle through VCU. Most of them, they are doing it through VCU because VCU is the ultimately heart and brain of the, I would say, brain of the vehicle. So with that, they are working on implementing the cybersecurity measures. And I'm sure government will introduce in the right time so that we'll not face such kind of challenges. Sure.
Thank you for cooperating. And again, there is one more question. There are one company that are converting all Activa Jupiter scooters to EV. Are these officially approved to operate in India? What standards and regulations are applicable in such use case? Am I audible?
I'm not sure, like whether his question is connected to global data connected with
correct,
company's
correct.
auto service system. See, there are plenty of companies working on it. You know, if I take about the Tesla itself, they do work on this role of collecting the data. You know, they collect real-time vehicles and battery data, and you know, they give it to artificial intelligence, and they also work on this predictive maintenance and automated driving. And talking about the Bosch, okay, it also provides IoT platforms connecting the mobility and vehicle data analytics solutions. So if I keep talking, even there are companies like Microsoft who actually offers cloud platforms for connected vehicle data storage, AI, and analytics. You also have Amazon Web Services, what we call AWS, which also provides cloud infrastructure for connected vehicles, battery analytics, and talking about the companies like Google Cloud, IBM is also working on, they uses this AI and IoT platforms for predictive maintenance and battery health monitoring system. We're talking about, we have plenty of companies working on this, NVIDIA, Qualcomm. So see, if I want to talk about Indian companies like Infosys, Tech Mahindra, Wipro, Tata, okay, even the L&T, they're all working on, they're contributing to this vehicle platform, digital engineering, data analytics. They're also working on automotive IoT systems, cloud-based mobility solutions. So we have industry working on this, and you have plenty of case studies also. Maybe they can connect to me offline. We can even have some more discussion on this. I hope I've answered the query.
Thank you so much, sir. And thank you everyone from the audience for participating in this contest. As we conclude today's webinar, it is evident that India's transition toward a net zero future is being driven by innovation, policy support, industry collaboration, and technological advancement. Today's discussion highlighted the importance of next generation battery technologies, smart charging infrastructure, grid modernization, AI driven energy management, sustainable manufacturing, and skill development in building a robust EV ecosystem. On behalf of Technozone Print Media, I extend my sincere gratitude to all our distinguished speakers, moderators, partners, and every participant who joined us today. Your insights and active participation have made this session truly meaningful. Thank you once again for being with us. We look forward to welcome you at our future knowledge forums and industry events. Stay safe, stay connected, and together, let's continue driving the future of sustainable mobility. Have a wonderful day. Thank you.
Thank you.
Thank you.
Thank you, Vaniti. Thank you, Jyoti.
The recording has been stopped. Thank you for joining. Goodbye.